Today I will talk about the link between the plastic consumption and the pollution in marine ecosystem in general, but we'll have a focus on Hong Kong, and I will give you a few examples of what are the findings in terms of plastic debris in Hong Kong waters. So before to go really into the detail of what are our findings, I want to start with some basic information about plastic and really definition. So plastic are from a combination of synthetic or semi-synthetic organic small molecules that we call monomers. Monomers are ethylene, for example, or polypropylene. So these two monomers will combine together to create very long chain of very long molecule that we call polymer. And why we say they are synthetic is because all these monomers are produced based on fossil hydrocarbons. So for example, we have different, depending on the composition or the combination of the different monomers, we can have different plastic or different polymer. So PET, it's one of them, which is polyethylene terephthalate. So if we look at the composition, it's combination of dimethyl terephthalate and ethylene glycol. And again, this composition of this combination of small molecules create very long molecules that are very resistant, and it's why we developed the plastic for their capacity to be very resistant. Now, approximately 90% of the plastic are this polymer. An additional 10%, it's what we call our plastic additive. So it's other type of chemical that are added to change the characteristic of the plastic, to make them softer, to change the color, to make them more easily malleable, to make different shape. So plastic in general, the word plastic is combination of very long polymer molecule plus additive. And we'll come back to the importance of the additive later. So the first plastic were synthesized in the late 19th century. And there were semi-synthetic molecules called celluloid, and they were used to replace ivory in beer bottle, for example. So this was the first use of plastic. In the first part of the 20th century, we developed PVC, PET, PE, so which are all plastic that we still have and we largely use today. But the game changer in the plastic production was World War II, where natural resources were much more difficult to access. So the industry turned to synthetic molecule, and they turned to plastic. And then they find that plastic are very convenient. They are very light, resistant, and high durability. So just after World War II, the industrial production of plastic really began. And this is a picture from Life magazine in 1955 that show a change in the plastic consumption. Plastic from the mid-1950s was used in our daily life. And if you look at the first synthesis on the article here, it's the object flying in the air. In this picture, would take 40 hours to clean, except that no housewife need to bother. So plastic are now, since that time, used in our daily life as a very convenient way to replace any item. It's cheap, it's easy to use, they are very quite affordable. So we change, our society changed the lifestyle we have to something much more convenient, and it was the use of plastic. So when we look at the production of the plastic based on this change of lifestyle, we can see that approximately in 1950, we produced 2 million tons of plastic. And here by approximately 1965, it was 15 million tons of plastic. Today, the more recent estimates are like between 350 to 400 million tons of plastic are produced in 2018 or 17. So you can see the production of plastic in the world have a very rapid increase. And it has been estimated that half of the plastic we produce since the beginning of the production of plastic have been made in the last 15 or 13 years. So again, a very rapid increase in the production. And this it's really, again, due to our needs or our willingness to use much more convenient item. So if we look a little bit more in detail, it's the same. It's the production of plastic by time. But just what I want to focus here, it's the type of plastic or what they are used for. And you can see that almost half of them are used for packaging. So very specific use, packaging. And we'll come back to that at the end. So where the plastic are produced, approximately, it was in 2013, the numbers that I'm showing here, half of them are made in Asia. They are made in Asia for the consumption in Asia, but also elsewhere. They are importation and exportation, of course, of plastic. And from this half, approximately 30% are made in China. And both production in Asia and China follow, of course, the trend of the global increase of the demand. So you have more demand for the plastic, you have a higher production, and of course the country that lead the production or have a rapid increase. So this is just the production of plastic in China to the time, 2005, 2015, and you see you have almost double the production in only 8 or 9 years. So we have more and more plastic that are produced in the world. Now we have more and more plastic, and we find more and more plastic in the ocean. So it's really driven by the rapid increase in the production and on our usage of the plastic. In 2010 only, just for the year 2010, it was estimated that between 4 and 12 million of plastic have been put in the ocean. Where they come from in the ocean, the sources are very diverse. River, it's one of the most important sources in the plastic in the ocean, and we'll come back to that later on. Atmospheric transport, the wind, heavy wind will bring some of the plastic if they are not well disposed. But also beach littering, it's another source. And also direct littering from aquaculture, from cruising. We mentioned that we look at cruising impact in the port yesterday, but they have also an impact in the ocean directly. And the first study that reported plastic in the ocean was in the 1970s. So only perhaps 20 years after the first, really the big development of the plastic production, that we start to find some in the ocean. And it took a little bit longer, but 20 years after, somebody started to look at smaller piece of plastic. So when we look at plastic debris in general in the ocean, we can separate two types of plastic. We can separate the microplastic, which are the plastic that you can see here, and just by the name, it's the big piece of plastic, and the microplastic, which are the ones that are shown in this picture, that are much smaller. So the definition for microplastic, it's pieces that are smaller than 5 millimeters. And this microplastic comes from the degradation of the bigger pieces. So the sunlight, the wave, the wind will impact and will, if you want, break down these big pieces to give these smaller pieces. For the last 20 years, a lot of the research has been focused on these small pieces. Why? Because they are much more difficult to remove, so their impact is potentially much more harmful for the environment in general, and also because they are much smaller, they are present everywhere. We have this microplastic, we found microplastic really everywhere. So if you look at a global map, we found microplastic in the surface of the ocean, of course, but also in the deep, at the bottom of the ocean, in the deep trenches of the ocean, in the North Pole, in the equator. We have microplastic, I think, really everywhere in the ocean. Now, what we have, we don't have the same quantity of microplastic everywhere in the ocean. And we have areas where we have concentration of this microplastic. And this map, so the circle, the pink circle here, shows the concentration of microplastic. And what you can see, they have in the middle of the ocean area with higher concentration. This corresponds to natural concentration or natural wind pattern that create the surface gyre of the ocean. And this wind pattern will concentrate the microplastic. And if we look more precisely at numbers, so these are the scale, and it's pieces per kilometer square, you can see that we can go up to 100,000 or even million of microplastic per kilometer square in this gyre. Now, if we look in detail, we have the gyre where we have a lot of microplastic, but also coastal area. So this concentration of microplastic, so here you can see these are the small plastic below 5 millimeter, and these are the quantity of the bigger plastic, the microplastic. And again, microplastic are much more abundant in the ocean than the big pieces. But again, they have very large variability. So now if you look in Europe, so in the coast of Ireland, so you see the size of the dot represents the concentration of microplastic again. So these are the unity, it's pieces per cubic meters. So you have a range between 0 up to 25 pieces of microplastic per cubic meters. If you go with a transect from Northern Europe up to South Africa, you can see that the range of microplastic will vary between 0 and up to 8 particles per cubic meter, with a very average around 2. Now, if you look in Asia, and more particularly in Hong Kong, what do we have? So this is a combination of different concentration of microplastic for different areas. So if you look at the Pearl River estuary, we have an average between 0 to 30 particles per cubic meter, which is higher than what we found in Europe, for example. Now, if you look at the Yangtze River, we have data that show that we have up between 500 to 10,000 particles per cubic meters. So we have much more particles in the coastline of China and Hong Kong than in Europe. And it's the reason that in the microplastic research field, Asia has been really pointed as a hotspot for the microplastic and the plastic pollution. Now, when we look at plastic, we can look at the quantity, but we can look also at the type of the plastic. So this is one sample from Hong Kong, for example, from surface Hong Kong waters, when we look at the different type of plastic. So you can see easily that we have what we call fibers, so very long particle, plastic particles, or small ones that are fragments. So definitely we can easily see the destruction of the big pieces to give these small fragment pieces. And this, for example, it's a sample that we need to sort. So from this one, we will separate the fiber, the fragment. But we can also separate them by their composition. As I said, they have several types of plastic, PVC, PE, PET. So we can try to separate them by composition. So visually, it's not easy, and the only one we can separate it visually, it's polystyrene or expanded polymer. It's what I show you here. If you have an image of the box of polystyrene, you can see that a small granule will end up something like this. So we can manually separate and pick all the polystyrene or the expanded polymer that are found in the water. And something that have been found or start to be really to point out that in Asia we have much more polystyrene or expanded polymer than any other places around the world. So we have polystyrene in Asia. It's true in Taiwan, it's true in Hong Kong, it's true in China, and it's not true anywhere else in the world. So we have something specific here, and we don't understand, or we don't know for sure why. We don't have the data to prove why, but definitely it has to be linked to the consumption. Are we using more, and for what type of usage are you doing this, or are you reusing the polystyrene? So because we don't have this direct link, we tried with one study, recent study that I did in my group, we tried to understand what is the link, where does the polystyrene in the water come from. So we just went to a beach in Hong Kong, and we look at the composition of the microplastic or the big pieces also here in the beach, in the water, and we just select one point just when the wave breaks. So if you look at a beach, when the wave will break because it reached just the level, and we look at that particular location because it's a lot of movement. So we wanted to see the dynamic of the particle where we have a lot of movement. And then we look at another point much farthest in the water. So what I want you to focus here, first here it's the beach area. This is what we call the boundary, so where the wave breaks. And this is the water. Now if we look here, it's the bigger pieces, bigger than 5, so it's microplastic. And here it's microplastic. If you just look at the blue, which is the polystyrene, the expanded polymer, what you look at is you have a decrease in polystyrene between the beach area to the outer near shore, to the water. It's true in the big size fraction, in the microplastic, but it's also true for the smaller microplastic. So it means that the polystyrene itself will stay, it's later in the beach, it's put in the beach, and then it will stay more easily in this area. It will also it will stay in the beach and also focus in the breaking wave when the water moves. It will not be transported farthest. This is not the source. In opposition, if you look at the yellow, which are what we call plate, or it's really packaging, if you want, you can see the opposite. We have a tendency to increase their concentration. So this type of plastic will be transported from the beach up to the water. So this is a really preliminary data that it's trying to help us to understand the dynamic. We know that we have littering of plastic on the beach. Then what will be the consequences for the water nearby? And when we look at just for the same setting, the quantity of plastic, we observe, so the red area, it's the boundary, and the blue, it's the more open water. You can see that you have really a concentration of the microplastic here when the waves breaks. And this is important to know. For example, if we do beach cleanup, or if we want to collect this micro particle, we show here that we should focus on that area. Doesn't make sense to go too fast because we have much less microplastic. Now I want to focus on, we have microplastic in the water, but we have also organisms in the water. And the organisms, the big one or the small one, will eat plastic in general. And I think most of you heard the news last week by the whale who was found dead in Thailand with 80 plastic bags in their stomach. So whale and mammals in general will ingest big plastic pieces, but also small plastic pieces. Oyster, mussel have been found with microplastic. Plankton, the smallest organisms in the ocean, have been found by ingested microplastic. Where we have the most data, it's for fish. And clearly, fish ingest microplastic. And what is interesting for fish, now we have enough data to look at different spatial, or to compare the viability, the spatial viability. So these are data from Hong Kong. So we look at, in blue, it's the frequency, so the quantity of fish that have ingested plastic in our study, and in yellow is the number of pieces that we found in the stomach of the fish. And this, it's with different species, and it's different location in Hong Kong. What I want you to get from that, it's very general. It's what we observe, that we don't see any species difference. And in average, we have between 60 to 80%, or even up to 100% of the fish that have microplastic in their stomach. When we look at the comparison in the location, I want just to focus on this one, which is fish from a fish farm. And we don't see any differences between the fish that have been naturally catch in the water or the one from the fish farm. So fish farm have been put forward to be one of the area where we have more microplastic just by the manipulation they are doing, and they are on top of the water. Our study doesn't show that we have much more microplastic. They have another study in Hong Kong who also look at that, had the same conclusion. Now, if we compare these numbers with numbers from other areas, for example, in Europe, they have been found that between 10 to 30% of the fish have ingested microplastic. In the Mediterranean Sea, which is also considered as a hotspot of microplastic, it goes up to 60% of the fish that have ingested microplastic. So here we are between 60 and 100%, which is higher. They have one study that has been done in the coastline of China, and they looked at all the fish. So 100% of the fish that they look at have ingested microplastic. So definitely, marine organisms are impacted by the microplastic. We find them in their digestive tract. Is it dangerous for us, for the human consumption? We don't know. More and more studies say that the microplastic stay in the digestive tract, doesn't move in the muscle of the fish, for examples. What we are worried, what the scientists are worried here, is the plastic additive. If you remember, I said 10% of the plastic are additive, different chemicals that are added to change the characteristic of the plastic. This additive now can be found in the fish. So there are more and more studies that show that we have not a transfer of the plastic itself, or the piece itself, but more of the chemical that can be relogged from the plastic in the fish to the fish meat. The last thing that I want to show you on the microplastic in Hong Kong, it's a study on specific type of plastic that are microbeads. So microbeads are microplastic they are smaller than 1 millimeter, and they are found only on the cosmetic and personal care products. So they are used as exfoliants in facial scrub or in toothpaste, in some of the toothpaste that are found also. Microplastic are only used in this type of product. And microplastic will just go through the water to the drain, and then will be treated by the wastewater treatment plant. And the wastewater treatment plant are quite efficient to remove the microbeads. It shows between studies that they can remove up to 98% of the microbeads. So they are quite efficient. It's between 85 to 98%. However, when we look of surface water of Hong Kong, we find that more than half of the samples have microbeads. So we know that they are well retained by the wastewater treatment plant, but we still find them in the water. So it means that you have really a lot of input of microbeads in the water to still find them in the surface water. And when we compare the quantity of microbeads in comparison to the microplastic in general, we find that it's approximately 5% of all the microplastic that we found in Hong Kong waters that are microbeads. And the microbeads issue have been, I would say, discussed for the last 5 years by a lot of countries, because countries ban products who have microbeads in their composition. Also, private companies like Johnson & Johnson, they changed their formula, they changed their product to ban the microbeads, because it's one type of microplastic that is it's an easy way to stop them. You put them in the plastic, in the cosmetic product, then you don't have them in the environment anymore. And they have a lot of natural way to have some scrubbing. So again, why we have all of this plastic? And I said the source of the plastic, the most important source of the plastic in general, are rivers. And a recent study in 2017, they compiled and the potential impact of all the rivers in the plastic that have been put in the ocean. And they found that 80% of the plastic that we found in the water is linked to the release of Asian river. So they're finding it's really Asia and Asian river are very big part of the input of plastic in the world. The first one is the Yangtze River. So if you remember, clearly we have very high concentration of microplastic at the opening of the river, so we are not surprising. The third one is the Pearl River Delta or area. So it's the Pearl River and Hong Kong are located in a really hot spot in terms of input of plastic in the ocean. So why we have so much plastic coming from the river? So if we just focus on that diagram, which is the life life journey of a plastic. So if we just look at the production, so production of new plastic, then some will be used, and we estimate that approximately 30% of the plastic that we produce is still in use, which means that 70% have been discarded. What are the options? So now if you look at here, you have in black line, it's all the plastic that we have generated up to now. The three options for the plastic that is not in use, it's either they are recycled, and it's this line, and it's the line that it's in blue here. So if you look here, then if they are not recycled, they could be incinerated, which is another way to dispose the plastic, and it's this quantity, and it's the green line here. But most of it, as you can see, is just discarded. Discarded in landfill or just in the land with no proper management. So this, if you look through the time, it's from 1950, the beginning of the plastic production, up to 2050. So if we just stop here in the middle, you can see that very little is in fact recycled or incinerated. It's approximately between 5 and 10% for each. So a big quantity of the plastic that is discarded, that is not used, it's discarded in landfill. And this brings issues in the management of this plastic. So we don't recycle the plastic, we just put it in the landfill. Or just, and this is the main reason. If you look at waste management or mismanagement, you can see this in tons of waste that are mismanaged. See that China and Asia in general came first as mismanagement of the waste. And it's the reason that we have so much waste or plastic waste in the river, because we have a problem with the waste management. And in fact, they estimate that the 5 countries that bring their input the most of plastic in the water are China, Indonesia, Philippines, Vietnam, and Sri Lanka, where they are the highest mismanagement rate. Now China make a big step to tackle that. Last year, they said they banned the import of plastic waste. So every country used to send their recycling plastic to China, who China had to deal with that. Now they stopped that. So each country have to deal with their own plastic waste. And it's really a game changer in the waste management, because countries or cities that used to have very high recycling rate by sending their recycle to China now will have to face and deal with their own recycling capacity. And in fact, the recycling capacity for plastic is very low in a lot of countries. Here it's an example in Hong Kong. So this is the plastic waste in Hong Kong and the proportion that is recycled or discarded through the time. It starts in 2010 up to 2015. What you see that we recycle less and less plastic in Hong Kong. We don't have the capacity, we don't have the facilities to recycle the plastic. And why? Because recycling plastic is costly. And today it's much more expensive to recycle the plastic than to produce new plastic. So they have no incentive, or at least monetary incentive, to recycle plastic. So it gives us very, very low rate of recycling. We are with approximately 10%, it's exactly what I show in the worldwide data. So those plastic a bad thing? No, I think plastic, and we saw, and plastic can be useful. What is the problem with the plastic? It's single-use plastic. And it has been estimated that 40 or even more, up to 17, depending on what are the numbers, of the 70% of the plastic that we are producing, it's to be used once and then discarded or recycled. But only 10% are recycled. So at the end, all of them, or most of them, will be discarded. So the problem with the plastic is the way we use the plastic. And if we can change that, this will be part of the solution. Reducing the quantity of single-use plastic will really help to manage the plastic. So just to conclude, that the estimation said that the peak of plastic production is believed to happen in 2100. So it means we still and we will continue to produce a lot and a lot of plastic. With this exponential curve, it means we need to do something in terms of waste management. And we have, I show you that they have really impact of plastic, big plastic pieces, microplastic, in all the organisms. And we still don't know the consequence of additive on their health, or the marine organisms' health, on our health if we ingest fish or seafood that have been contaminated. So we definitely need to make a better management of the waste by using more or developing more recycling facility, but also by changing our consumption and limiting the use of single-use plastic. Thank you.
So ladies and gentlemen, questions for Christelle?
Yeah, it's very nice talk. I know UNEP is considering initiative that a wall to plastics for the place. So you mentioned these 5 top countries discharge the most plastic waste into the ocean, to the China, Indonesia, Philippines. Do we know the percentage contribution from local consumption and importing the solid waste?
No, it's not. No, we don't know, and it's the reason all these countries are the country that collect and import the recycling from Europe, from America. So it's not only their own consumption, but we don't know exactly the percentage.
Because this is a very good example. Requires the global governance, not only the one country, and also the management at the global scale and the individual region.
I think the step that China took last year will completely change, because now other countries...
China banned the import, but it looks like they loosened again. Some of the pressure from all this Europe and the US, all this ban the waste import.
Any other questions?
Hi, I just wondered if you could speculate on the link between aid, international aid, investment and waste collection in the Pacific. Because a lot of the islands, there's huge amounts of waste turning up, and the governments just haven't got the capability to manage it, and they do need new technologies. And I just wondered whether you knew anything about that area.
Yeah, so there are one thing that, as simple as it is in terms of waste management, is just collecting the waste. Just the collection, having the less waste on the street will help already. So it doesn't have to be advanced in terms of recycling or even incinerator. Just the first basic step will really help. They have studies that show that picking the waste from the street will help. So even in country or island that they don't have big facilities, just collecting it, I think, will help.
So what do they do with the waste? It's a huge volume, and they've got no real capacity for landfill. So it has to actually be either converted into oil or kind of moved away. So
Send it to China.
The best will be that to convert them, but this is expensive and they need facilities for that, and it's the final goal of the recycling. But again, you need to invest either in proper storage of the waste or landfill, or then recycling.
One last question, Ken.
Thank you, Christine. One observation, in recent months, when the oil price increased, now the recycle company really happy. So they collect the plastic bottle and recycle. Last few years we have big problem. So somehow, maybe just like Daniel said yesterday, we can, so without subsidy for fishery, perhaps we need to charge more for petrol and fuel.
Yes, they have ideas that if companies can have a tax, then it will help to have more or better recycling or subsidize recycling that can be much more efficient. It's just now the competition between recycling and producing new plastic. It's just too cheap to produce new plastic.
And just two interesting study published last year. One is the Japanese Fukushima tsunami discharged lots of plastic waste. And then in US coast, they found lots of Japanese marine species now because the animal hijacked and anchor on those plastic. The second one is they also found that the plastic is a vector of disease. So this is, if this is real, that would be a quite big problem to the global.
Yes, but I think tsunami we can do anything against. So we have to deal with that when it will happen. But
I mean the plastic can be vector for biological invasion and also disease.
yes, in the long, definitely, and the transmission of the movement of the plastic and invasive species, chemicals, contaminants. They have also studied that look at heavy metal that have been attached to the plastic, not only the one that come from their structure, their molecule, but the one that have been attached, and biofilm that have a lot of processes that can affect and even make it more dangerous.